Hello everyone, and welcome back to another REPL speedrun. Today we'll be speedrunning units 9.1 to 9.5, which are all part of sets. But first of all, we need to answer the question, what is a set? So, to best understand a set, you might remember a set from mathematics. It's something containing certain numbers. So actually, let's call our set A. So if our set A has numbers 1, 3, 5, and 7, and that's about it to a set. It just contains certain elements. I do believe that you can have strings in sets, but for these REPL challenges, we will only be needing to tackle sets that have numbers in them. So let's say 2, 3, 5, 8. And that's about it to a set. So there are some unique things about a set. First of all, sets can only have unique elements. For example, if we try to add a 1 to the set, can't do that. It's not allowed. And the other thing you need to understand is how do we compare sets around, right? So if we have these two sets over here, and we can imagine them in a Venn diagram. So if we have, say, this is set A, and this is set B, we can fill out this Venn diagram. So what's unique to set A is the elements 1 and 7. What's unique to set B is the elements 2 and 8, and what's in both sets is 3 and 5. And we're going to have to perform operations to get these different parts of the Venn diagram. So, if you remember from math class, this part is called the intersection of A and B. So, in Python, that's denoted as A and B. And this will return a set with these two things. So, if we have A and B, then this will be equal to 3 and 5. What if we want the union? The union is both sets combined. If we want all of it, well, we have to, put that back. We have to use the union symbol, which in Python is the pipeline, or just a straight line. So A union B is equal to 1, 2, 3, 5, 7, 8, I believe. And we do have other operations that we can perform on sets, but I'll introduce you to those when we reach them. Now, the final thing we need to know is how to convert between a set and a list, and it's very simple. If we want to convert this set A to a list, we can simply put list A. And if we want to convert a list back into a set, we can use this notation set, and then we put our list name inside here. So let's get on to some challenges. First, challenge, we're given a list of integers, count how many distinct numbers it has. This task can be solved in a simple line. So this utilizes the fact that sets can only have distinct numbers. So if we try to add a number to a set that's already in the set, it will just do nothing on the set. So to solve this in a single line, let's first input our let's input this list. So we can have int I for actually we don't even need the int. It's just I for I in input dot split, and the only thing we need to do is convert this to a set, which will remove all of the duplicate elements, and it wants to count how many distinct numbers. So this set contains all of the distinct numbers, so we simply have to get the length of the set and then print the length of the set. So if we try to run this on our example input 1, 2, 3, 2, 1, as you can see, it prints the correct answer 3. And let's show you why. What I mean by a set. We haven't looked at one in Python yet. So if I take this, put it here, then and if I put this input, as you can see, this is our output 2, 3, 1. And it's removed all of the duplicate numbers, so it only has the unique elements remaining, and that's why this code works. So as you can see, we've solved this problem on a single line. So let's move on to the next problem. Sets given two lists of numbers, count how many numbers of the first one occur in the second one. And we're going to do this, we're going to have to use our friend, the union. The intersection, which gets the numbers in one set that are also in another set. So first, let's input our two sets. So we have, I actually believe we can use these curly brackets. Call our first set A is equal to I for I in input.split. Let's just test this works. I'm not too sure if it will work. So we copy our input in, and okay, I guess it does work, so it's all good. So then we can have our second set B, which is also just going to be everything in the input.split, and we need to count how many numbers of the first one occur in the second one. First, let's get the set, the intersection between A and B. So what this will do is it will return all of the elements that are in both A and B. So if we run this code, it is not returning anything. Interesting. Let's print A and B just to make sure we're getting the correct sets. 3, 1, 2, 2, 3, 4. Oh, sorry, we're not printing the intersection. I thought none is just the return value. So if we print the intersection now, as you can see, we get the elements that are in both sets. So to get the number of numbers, we simply have to get the length of the intersection, and this will return the number of numbers in both sets, which in this case is 2. So that's how you solve this problem. Okay, our third challenge is given two lists of numbers, find all the numbers that occur in both the first and the second list, and print them in ascending order. Okay, so first let's copy our input code over here. But instead of getting the intersection, we want to get the union of these two sets because we want to get all the numbers that occur in both the first and the second list. So we can call third set union is equal to A pipe B and, A pipe B. Okay, and then if we print this union, we'll see, I believe that it is unsorted. See, it's in a random order, and we want to print the numbers in, find all the numbers that occur in both the first and the second list, sorry. So it's still going to be intersection. Okay, and if we print this, then we get these two numbers. But the thing is, they're not sorted. So we want to sort these numbers into the correct format. So we can try something like intersection.sorted, which sorts this list. Sorry, the set. But as you can see, the set object has no attribute sorted because sets don't have an order. It doesn't matter whether you put in what order you put in elements. So to get a sorted list, we're going to have to convert this intersection back into a list and then sort that list. So if we copy our input, sorted. We have to actually, it's a method. So let's try sorting the intersection again. I'm not actually too sure if you can sort it. Maybe I was wrong. I think I was wrong. So as you can see, it sorts the intersection, but returns a list instead of a set, which is perfectly fine for our purposes. And so this gets the correct answer. So sorted is a method. I thought it was an attribute of this intersection class, but apparently not. That's fine though. We still got the correct answer in the end. Ooh, no. Ooh, it is. So the thing is, we aren't converting these into integers, so it actually thinks that this 12, because there's a 1 in the front, should be sorted higher than this 2, because it is a 2 in the front. So we actually want to convert these into integers over here. And if we run this code, as you can see, there's no more quotation marks, so it means it's converted into integers, and therefore this code should work. Right. Now, to the next challenge, seen before. Given a sequence of numbers, scan them from left to right, and for each number, print yes if this number was already seen, or no if you've seen it for the first time. Okay. So we want to first input this list of numbers. So I guess we can go our list L is equal to I for I in input dot split, and we want to make an empty set. So it's called S equals set, and that's how you make an empty set. We don't want to use these empty curly brackets because this actually means that we're creating a dictionary, which is a different thing, and we'll get to that in the next unit. And so now we want to loop through our list. So for element in L, we want to check if this element is in the set. And if the element is in the set, it means we've seen it before. So we can skip it. Otherwise, we want to add it to the set. So for element in L, if element in set in S, then we want to print no. But otherwise, we want to print yes, and we want to add the element to the set. So I think we can just use, can we not use append? Sorry, it's called add for sets, my bad. So s.add element. And this code is all there is to it. So if we copy our example input and run it, as you can see, I put these the wrong way around. So we're supposed to print yes if we have seen the element before and no if we haven't seen it. So this tells us if we have seen it, and this tells us if we haven't seen it. So sorry, let's try our input again. And as you can see, we have the correct output. So that's all there is to this problem. Finally, let's move on to the last problem in the set. Augustus and Beatrice play the following game. Augustus thinks of a secret integer from 1 to n, and Beatrice tries to guess the number by providing a set of integers. Augustus answers yes if a secret number exists in the provided set, or no if it doesn't exist. Excuse me. Then, after a few questions, Beatrice, totally confused, asks you to help her determine Augustus's secret number. So we're given the positive integer n, which is the number from 1 to n, but where can the possible number be? And we have a series of numbers separated by spaces, or Beatrice's plea for help. When Beatrice calls for help, provide a list of all possible remaining secret numbers. So to do this, to solve this problem, since we don't know how many times Beatrice tries to guess the number, we're going to have to use our old friend, a while loop from Unit 6. First, let's create a list of numbers from 1 to n. A set of numbers from 1 to n, which could still be the potential numbers. So potential numbers is equal to s, and as long as it's not an empty set, we can define it using these curly brackets. So we can say int I for I in range, and we want to make this input, and just printing this potential numbers first, just to show you what we get. So if we put 10 in, we'll get every, actually we should make this I plus 1, because range starts at 0. So if we put 10 in, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which are our potential numbers. And now we want to loop through Beatrice's questions. So we can say set question set is equal to our curly brackets. Actually, let's just make this input, and we want to now enter our while loop. So we want to just check if Beatrice has put help instead of an actual set of numbers. If she has put help, then we want to print the code. Otherwise, we want to continue. So while actually, let's call this result. So while result is not equal to the string help, we want to make a set of numbers from it and compare them with our potential number set. So first we want to create a set of numbers. So result set is equal to the set where we have int I for I in result.split. And now we want to check whether the second line is yes or no, which tells us if his secret number is in the set or if his number isn't in the set. So we can now put if input equals yes, then we want, if this means that his secret number is in this result set, so we want to get the intersection of this result set and this potential numbers set. So potential numbers, and the shorthand to do this is we can do and equals or ampersand equals with the result set, which sets, this is shorthand for potential numbers equals potential numbers ampersand result set, which, as you know, is the intersection between the potential numbers and the result set. Otherwise, if his input was no, then we want to get the difference between the two sets. So why? It's because his potential number is not in this result set. So we want to remove every element inside this result set from the potential numbers set. And we can do that by using minus equals result set. Finally, this will loop through until sorry, I forgot the most important step. Finally, we have to set our result to the next input, because this will then loop back through and check if the next input is up. So now we need to, when Beatrice calls for help, which means when this while loop exits, we want to provide a list of all the remaining possible secret numbers in ascending order separated by a space. So we can simply print sorted potential numbers, because potential numbers already contains all of the possible numbers that Beatrice could have. So if we put in our input, as you can see, it gets the example output, and so we have our code that should be working. Taking a bit long. I wonder if I've requested for an extra input. Nope, never mind. It was just REPL being a bit slow. And so, as you can see, we have now finished the sets unit on REPL. I hope you enjoyed the speedrun. and I hope that this made you more confident in your sets and your coding abilities. See you in the next one.